This video, we're going to do even more practice with radicals. You thought we'd done enough? No, we've got more to practice. So let's do this one a little bit more on rationalizing denominators. In this example, I've got the square root of 3 over 8. Step number one is always to double check, especially when you have fractions, that is it simplified? 3 over 8, can it be simplified any further? And the answer is no in this case. 3 over 8 does not simplify any further. So after you've done that, the next step really is, typically, is to split it apart. And so we know that the square root of 3 over 8 is the same as the square root of 3 over the square root of 8. And then we will simplify each of those radicals. Well, the square root of 3 does not simplify, but the square root of 8 is 2 square root of 2. And this square root of 2 in the denominator is what we want to eliminate. We do not want to have any square roots in the denominator. We've talked about that in class, that it's not mathematically necessary, but it is just a proper form that we prefer. So to eliminate that square root, we know that whenever you just multiply a square root times itself, it will become a rational number. So we're going to multiply both numerator and denominator by the square root of 2. And multiplying the numerator, we get square root of 6. Square root of 3 times the square root of 2 is the square root of 6. And in the denominator, we have 2, and then we have radical 2 times radical 2, which gives us 2. So we have 2 times 2 in the denominator, which gives us our final answer of the square root of 6 over 4, which does not simplify. Don't try to simplify that square root of 6 with the 4, because you can only simplify square roots with square roots. You can only simplify the numeric value, not the rational numbers with rational numbers, and square roots with square roots, and cube roots with cube roots, and etc. Let's look at another example. Now we have cube roots. And we have the cube root of 12 divided by the cube root of 15. So the first order of business is to simplify, and the easiest way to simplify is to write it as one radical. Since they are both index of 3, you could write it with one radical symbol, 12 over 15. We want the cube root of that, and 12 over 15 does simplify. We get 4 over 5, because they're both divisible by 3. And now we have the cube root of 4 over 5. Since it's now simplified, we're going to split it apart, and we get the cube root of 4 divided by the cube root of 5. And we need to rationalize that cube root of 5. Since this is the index of 3, I need groups of 3, things to the third power, under the radical symbol so that I can clear it, so I can bring them out of the radical. But this is only 5 to the first, and I need 5 to the third. So if I multiply that by the cube root of 5 squared, I would end up with the cube root of 5 to the third. So let's do that to the numerator and denominator, multiplied by the cube root of 5 squared. The numerator, since they're both cube roots, they're just under one radical symbol, so I have the cube root of 4 times 5 squared. But the denominator is exactly what we wanted, the cube root of 5 cubed. The index and the power match, so I know I'm going to be able to clear that radical. But the numerator, I've got 4 times 5 squared, which is 4 times 25, which is 100. So the radicand, the thing that's underneath the radical symbol, is going to be 100. And so I end up with the cube root of 100 in the numerator divided by 5, which is in the denominator. And that is my simplified answer. The next one. Oh, this one, we've got, so much going on. We've got square root of 2 minus 3 in the numerator. And remember, we don't ever care. It's perfectly fine form to have a square root in the numerator. We don't want any square roots in the denominator. In the denominator, not only do we have two square roots, two different square roots, one of those square roots actually has a variable in it. But the method of eliminating square roots in the denominator when you have an expression is to multiply by its conjugate, because you want to multiply conjugate pairs, and that always eliminates square roots. So the conjugate of the square root of 5x plus 2 root 3 is the square root of 5x minus 2 root 3. So we will multiply both numerator and denominator by that. This requires us to go to some scratch paper for a moment here and look at our numerator. And the numerator, I have those two, I think of them as binomials. It's the square root of 2 minus 3 times the square root of 5x plus 2 root 3. And I like the stacking method. I multiply straight down, and I get the square root of 10x. Remember that x is under the radical symbol. Nothing comes out of there. And then I multiply the next one straight down, negative 3 times 2 root 3, and I get negative 6 root 3. Then I'm going to multiply the diagonals. Root 2 times 2 root 3 gives me 2 root 6. And the other diagonal, negative 3 times the square root of 5x, which is negative 3 square root of 5x. None of those radicals are alike, so there's no collecting to do, there's no simplifying in that part of it. That's it. That's the numerator, and so I'm going to write it up on top where I have my, my problem. So that's the numerator, all of that mess. Now, I still have the denominator to take care of, but it is a conjugate pair, and remember, it's the first term squared minus the last term squared. So it's the square root of 5x squared minus 2 root 3x. Well, the square root of 5x squared is just 5x. But the 2 root 3 squared would be 2 squared times root 3 squared, so I get 4 times 3. So I got 5x minus 12. But that goes up above as the denominator. I wouldn't split this one apart because I've got an x, I've got this unknown. This has got a lot more if I was going to solve this problem, or I don't know what we would do with this further, but I wouldn't split it apart like we've done when we had numeric answers. But this is where I would leave it. And so there's your final answer. So that's even more with radicals.